Recall that one of the assumptions of kinetic molecular theory is that gas particles are very far apart compared to their small sizes. Because of this, gas particles can behave independently. That means to us that the identity of the components of a gas mixture doesn't really matter, and that gas mixtures can behave like pure gases. Each part of a gas mixture is said to exert a pressure, and we call that its partial pressure. Dalton's law describes the relationship in a gas mixture between the partial pressures and the total pressure of the mixture. You can read Dalton's law right here. It says the total pressure of the gas mixture is the sum of the partial pressures of the gases in that mixture. So what it means to us, P total, this would be all the gases in the mixture. And the other P's on the other side, the P1, the P2, the P3, and however many there could be, this is just an example, these are the individual gases. And these are their partial pressures, or the pressures that they would exert if they were all by themselves. Now, it's very common for Dalton's law to be used with other gas laws, such as the ideal gas law. But in this case, I just want you to qualitatively understand what Dalton's law is saying. To do that, I think it's easiest to see an example where we have some numbers to plug into the equation, so you get kind of a visual of what's going on. So this problem says, if you had nitrogens added to a balloon that already contains oxygen, so here's oxygen, and it gives us, this is the pressure of oxygen. It also contains carbon dioxide, and this is the pressure of carbon dioxide. And then it tells us that to give a total pressure, once you add the nitrogen, the total pressure is 850 millimeters of mercury. So the question is, what is the nitrogen's partial pressure? Well, Dalton's law tells us that that total pressure, that 850, has to equal the pressure of the oxygen plus the pressure of the carbon dioxide plus the pressure of the nitrogen that has been added. So that's what it's telling us. The total is equal to the sum of each pressure. So we know that this is 850 millimeters of mercury. The oxygen is 450 millimeters of mercury plus 150 millimeters of mercury for carbon dioxide plus the pressure of the nitrogen. So if we take 850 and subtract 450 and 150 for the oxygen and the carbon dioxide, we have 250 millimeters of mercury, which would remain, and that is the pressure of the nitrogen. So when we subtract, remember that the total pressure of the mixture is equal to the sum of all of the partial pressures.